You are currently sitting at a depth of 3,280 feet, or about 1,000 meters below the surface of the water. The very last ray of sunlight disappeared 2,625 feet, which is about 800 meters above you. The pressure crushing against your body right now is 100 times greater than it was when you woke up this morning. The water temperature is 39 degrees Fahrenheit, or roughly 4 degrees Celsius. It will not change from here on out. Your gauges confirm what your eyes already know. There is absolutely no light down here, none from the surface, none from any outside source. Physically, optically, measurably, zero. And then something switches on a red light, not white, not blue, not that cold green color you have seen from other creatures at this depth. Red. You measure the wavelength. You measure it again. The number flashing back at you simply cannot exist. Red light, with a wavelength over 600 nanometers, is completely absorbed by ocean water before it even reaches a depth of 656 feet, which is around 200 meters. You are down at 3,280 feet, or about 1,000 meters. That color of light physically does not exist at this depth. And yet, something is making it, and something has evolved specialized eyes just to see it. Here is what the official record shows. Malacosteus niger, that is its name. It is one of only 4 species in the Stomidae family capable of producing red light in the deepest layers of the ocean. It was first documented back in 1864, but that extraordinary ability was not truly understood until the 1990s. Its body length is about 10 to 11 inches, which translates to 25 to 28 centimeters. Its skin is an absolute pitch black color that absorbs 99.95% of all light hitting it. Its jaw can swing open nearly 120 degrees, completely out of proportion to its body size by any normal biological standard. It lives in the bathypelagic zone, anywhere from 656 to 3,280 feet, which is about 200 to 1,000 meters deep. This is a stretch of water where 76% of all documented creatures generate their own light, but almost all of them use blue or green, because those are the only colors this environment can actually transmit. The dragonfish is the only fully documented exception with a red light system. The question is not why it produces red light. The question is how, and what is it broadcasting, and to whom, in a place where that color, by every law of physics, should be completely unreachable. This is what the record shows, or rather, what it showed before 1998. For 130 years, the widely accepted model went like this. Deep-sea bioluminescence is a tool, a lure to attract prey, camouflage to escape predators, or a signal to communicate with members of the same species. The entire lighting system in the bathypelagic zone was explained within this framework. Nobody challenged it, because the data gave them no reason to. The dragonfish fit the model. It has photophores, light-producing organs, lined up along its body. The assumption was that they were used for communication within the species. That made sense. That was accepted. Nobody questioned the specific color until a research team at the Scripps Institution of Oceanography decided to measure everything again from scratch. In 1998, a study by Denton and Herring analyzed the light spectrum of Malacosteus niger. The results showed that the photophores located right beneath its eyes emit wavelengths between 680 and 720 nanometers. That is deep red, just shy of infrared, and this is where the data starts to get weird. Ocean water absorbs 99.9% of red light before it even hits a depth of 328 feet, which is about 100 meters. At a depth of 3,280 feet, which is around 1,000 meters, red is completely wiped out from the environment. Every other creature at this depth has evolved without any visual cells sensitive to red, because there is no reason to have them. There is no red light down here to see. Broadcasting red light at 3,280 feet, or about 1,000 meters down, is like setting up a radio transmitter station on a planet where no one owns a receiver, except for the fact that the dragonfish built its own receiver, too. Malacosteus niger does not just make red light. It actually has photoreceptors in its retina that are sensitive to wavelengths of 700 nanometers, a color that no other living thing at this depth can perceive. It built a transmitter, and it built the receiver right alongside it, two systems evolving side by side, a signal and a decoder, in a world where that signal should not even exist. But that is only the first puzzle. Think about what this actually means. The dragonfish has its own completely private optical channel, a channel that no other creature in those waters can log into. Its prey cannot see its high beams. Its predators cannot see its light. Its competitors cannot see its glow. Only other dragonfish can see it. This is an invisible communication system running constantly right in the middle of a crowded community of organisms, without a single neighbor knowing it is even happening. The dragonfish is not hiding in the shadows. The dragonfish is broadcasting signals, openly and continuously, on a frequency that the darkness is supposed to swallow up, and we have absolutely no record of what it is saying. The second problem is even harder to explain. Chlorophyll, the fundamental photosynthetic molecule of life, absorbs red light most efficiently at 670 nanometers. Malacosteus niger emits light precisely between 680 and 720 nanometers. One unconfirmed theory suggests that the dragonfish might be exploiting microscopic traces of chlorophyll-derived compounds in the environment. Reflecting back the light, its prey absorbs rather than just emitting it. The problem is that no biological mechanism has been identified yet. The hypothesis exists, but empirical evidence does not. Science does not have an answer for this. Not yet. And then came the year 2002. Douglas and Partridge confirmed that the dragonfish has bacterial chlorophyll C and D inside its retina. This is the exact kind of chlorophyll found in photosynthetic bacteria that live in shallow waters, not in a deep-sea predator living in total darkness. This molecule should not exist in the eye of a creature living where there is zero light for photosynthesis. The dragonfish did not evolve this molecule on its own. Current evidence suggests it gets the molecule from the bacteria it consumes, and then it repurposes it. It literally rebuilds its visual system around a compound it absorbs through its diet. We have never documented this kind of mechanism in any other vertebrate on Earth. If this hypothesis is correct, here is what it means. The dragonfish is the only known creature that can alter its own visual capability through its diet, not through generational adaptation, not through millions of years of evolution, but through digestion within the lifespan of a single individual. Depending on what it ate for dinner, it might see more or it might see less. The measurements were recorded. Researchers ran the tests again. Same result. A creature literally hacking its own eyes through what it eats. The exact mechanism behind how this happens is still completely unknown. 3 major questions have been officially logged. Not a single one has an answer. Question number 1. What are dragonfish actually saying to each other on this red channel? Mating calls, spatial navigation, coordinated hunting. We simply do not have enough live specimens to observe real behavior. Every single specimen captured is either dying or already dead by the time it reaches a scientist's hands. The extreme pressure change during the trip to the surface tears apart soft tissue before it can even be analyzed. Question number 2. How many other species are doing the exact same thing without us knowing? The bathypelagic zone has an estimated 2,000 to 10,000 undescribed species. The ability to produce red light might have evolved independently multiple times, just like bioluminescence itself has done at least 40 separate times across completely unrelated evolutionary branches. Question number 3. Where exactly does the chlorophyll in its eyes come from? Acquiring it through diet is a strong hypothesis, but it is not a final conclusion. No one has ever successfully raised a dragonfish in controlled conditions to test this, and nobody can until we solve the pressure issue during sample collection. Look closely at what all of this truly means. If a creature at 3,280 feet, which is about 1,000 meters deep, can build an entire optical system that went completely undetected for 130 years of observation, not because we were not looking, but because we were looking at the wrong spot on the spectrum, then how many other communication systems are up and running in the ocean right now that our gear is just not designed to detect? Europa, the moon of Jupiter, has a liquid water ocean tucked under a sheet of ice that is 6 to 19 miles, or about 10 to 30 kilometers thick. There is no sunlight. The pressure is astronomical. If life exists over there and uses a spectrum we have never even thought to measure, we would have no idea. We would look right at it and see absolutely nothing. The dragonfish did not wait around for sunlight to build a visual system. It built one out of whatever the darkness provided. That is not just adaptation. That is an argument. An argument that life does not go searching for the perfect conditions. Life looks for whatever is available and builds from there, no matter if physics says it is impossible, and you are still down at 3,280 feet, which translates to about 1,000 meters. The red light is still on. Now you know where it comes from. You know why it should not exist. You know exactly what kind of body is generating it and what kind of eyes were engineered to see it. But the question you started with, what is it saying, still has no answer. The light is still on. The signal is still broadcasting, as of the most recently recorded expedition, status unknown. There is one more thing the record shows. In 2020, a study analyzing the skin of Malacosteus niger discovered a nanoparticle structure that allows its skin to absorb 99.95% of all incoming light, including the exact same red light that it produces itself. In other words, the dragonfish does not reflect its own signal back. It broadcasts a color of light that cannot exist at this depth, and its entire body is engineered so it cannot be seen by that very same light. A transmitter inside an invisible object, operating at a frequency that the surrounding environment is not even supposed to carry. The deep still has so much more to show you. Documenting what the archives hold takes time. If you want to see what is coming up next before it ever hits the surface, the vault is open. The link is right down below. Coming up next, a creature down at 13,123 feet, which is about 4,000 meters deep, that has not eaten a single thing in 5 years. Its vital signs are still registering. The mechanism keeping it alive all this time remains completely undetermined.